What we're going to do with the first one is we're going to see if it's geometric first of all. It turns out this one is geometric. And what really stands out to me is how the top goes 1, 2, and 4. It looks like multiplication. That I'm just multiplying by 2 actually turns out to a negative 2. And the way we could see this with the 6 is I could turn everything to a denominator of 6. So you could have, if you wanted to, you could have rewrote this. If you didn't realize it, you could have said, well, let's picture this as 1 over 6. Let's picture that one is multiplying by 2, so that would be negative 2 over 6. Then we would have 4 over 6. And then we would have a negative 8 over 6. And then we'll notice on the top it goes 1, 2, 4, 8. That sounds like multiplication. Well, since it's multiplication, we don't have to. Remember, I gave you those two cases. Either I just treat the multiplication with the common ratio, or we could treat it with a negative 1 to the n minus 1. In this case, since it's geometric, just remember you can multiply by a negative value. So multiplying by a negative 2 would get me that negative 2 on top. Multiplying by a negative 2 would get me back to that positive 4. Multiplying by a negative 2 would get me to that negative 8. So this is a geometric sequence. For geometric, we just have to state the first fraction, which is 1 over 6. And we're going to multiply that by the r value to the n minus 1. You can move that negative 2 to the n minus 1 to top, so you could make it look like negative 2 to the n minus 1 over 6. Either one of those is acceptable. I am 100% fine if you're just like, I got my equation, get in, get out, next problem. But if you want to simplify it, you can. All right, questions on the first one? Our next one we're going to notice is a special case. It is not arithmetic, it is not geometric. As a whole, it's not geometric, nor is it arithmetic. However, if you just look at the denominator, if we just go, okay, if it's neither one of them, pull the denominator and numerator out. So we have 2, 6, 10, 14. That is plus 4, plus 4, plus 4. So the arithmetic version of that would just be, okay, we can go a sub n equals the first term, which is 2, plus n minus 1 times our common difference, which is 4. That would equal 4n minus 2. That's all the work we really need to do because we're going to have a 1 on top and we're alternating between positive and negative. So that's all going to be flushed out when we're writing our equation. So I'm just going to start out with okay, it's a fraction where I have 1 on top. I got 4n minus 2 on bottom. This does not account for it alternating between positive and negative because it's arithmetic. With an arithmetic sequence, I do have to put something out front, which we can put on top. What do I need to put out front to make sure it's alternating correctly? Yeah?
You make it so, first of all, you make it negative.
Gotcha.
And then you put it to the n minus 1 power because the first one is positive. So you're going to want to, if it's like a1, then you minus subtract it. And then it's, yeah. So,
yep.
Yeah, but it's n minus
1. I'm
1.
assuming you wanted a 1 in there, right?
Yeah. 1.
Yeah. Yeah, we want n minus 1, exactly what he stated. He wants the first term to be positive. See, if you plug a 1 in, we have 1 minus 1, which is 0. Negative 1 to the 0th is a positive 1. That makes our first term positive. Alternatively, you could just put that on top and say this is negative 1 to the n minus 1 all over 4n minus 2. Okay, let's go over questions from the homework. Real quick over those. What questions do we have from the homework? Isabel.
Can you do a 2?
Yeah. 2 says that we need to go from... So we have we have a summation of 3 to 15, and we have negative 0.1 n plus 1. So we're trying to come up with a sum, which means we need to have the first term. We need to have how many terms we have, and we need the last term. So I'm going to note that our first term isn't plugging in 1. So if we look at where this starts, it says start at 3. So although I'm going to write a sub 3, That still stands for my first term. That is still first term. So a sub 3 is still our first term. So we're plugging 3 into this, which would be negative 0.1 times 3 plus 1. And that's what's going to get out my 0.7. My last term is my biggest number, so that's a sub 15. That's plugging in 15. So we have negative 0.1 times that 15. I kind of like parentheses on there, plus 1. That would equal negative 0.5. And then our n value. The number of terms. I said we can count this by hand. We can go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or we can go, okay, if n equals 1 to 15, that's 15 terms. 2 would be 14. 3 must be 13 terms because I'm losing 2 terms. Alternatively, you can go 15 minus 3 plus 1. Because 15 minus 3 will get me how many steps you have. But then you need to add 1 for that first term. So if you're ever looking at this and just, I want to subtract these two, just remember you have to add 1 more onto it to account for that, that missing term. So however you come up with that, we should have came up with 13. Is that far enough? Okay, good. Other questions? Going once? Going twice? I'm not waiting a long time because buckle up. We got kind of a longer lesson today. All right, today we're going to talk about geometric sequences in series. Any finite series will have a sum. Anytime it's finite, it will have a sum. Whether it is arithmetic, yesterday we said arithmetic was that pair them off, do your first one plus your last one, multiply by how many pairs you have. That was our n divided by 2. Today, if it's geometric and finite, it's going to be important for us to note it's finite. We're going to use not as nice a formula. Our sum is going to be a sub 1, which is our first term. Remember, our first term might not necessarily be a sub 1, like the one that we just did. Our a sub 1 was actually a sub, I already forgot, 3? 3. All right. So a sub 1, that just stands for first term, times 1 minus r to the nth, all over 1 minus r. So once again, a sub 1, that's our first term. R is our ratio, that common ratio. N is our number of terms. Kind of really small number of terms. And we should know n is the number of terms by now. First term, ratio, that looks like ralio. Let's change that to ratio, and number of terms. We're going to start off with the hardest problem you can have with a geometric sequence. And that is one where you do not know your nth term. Now, if you remember, we're going to do the same steps we did with a geometric sequence. So I don't know how many we have in here, but I do know the first term is 1. My last term is that 1 over 243. So real quick, let's make sure it's geometric, I should say, and it is finite. So this is definitely finite. It does start and end. And to prove it is geometric, we just got to find a ratio, a common ratio. Well, to get from 1 to 1 over 3, we're multiplying by 1 over 3. To get from 1 over 3 to 1 over 9, we're multiplying by 1 over 3. So it's finite. It is geometric. And we have an r value that equals 1 over 3. All right, let's look back at the sum formula. What 3 things do we need? We need the first term. Got it. It's 1. I need the common ratio. Got it. It's 1/3. I need to know how many terms I have. Don't got it, because I have this ... saying that I don't have that thing. All right, so what we're going to do is we're going to set it up kind of like we did with geometric. I'm going to write the equation, and I'm going to use that to figure out what my n is. So our equation for this one would be a sub n equals 1 our first term times our common ratio to the n minus 1. Can someone help me? How do I use this to figure out what my n is going to equal? Yeah.
You can plug in 1 to 143 for an.
Yep, we're going to say, okay, I know my last term. We're going to plug in our last term, and that's going to help me find our n. That worked perfectly fine when we had that geometric sequence. We're going to run into a little roadblock on this one. And it's not the setup, it's the execution that's going to be the problem. So once again, you're going to plug in this last term, because this n is the same as this n. This is my last term. If I plug this in and solve for that n, I know what term I have here. So that's going to give me 1 over 243 is going to equal, well, I'm going to get rid of that 1. I'm just going to leave this as just 1 over 3 to the n minus 1. Two ways we can solve this. First way, we remember from Algebra 2 how to use logarithms. Anyone down for doing that? Okay, let's go the second way. The second way is a cheat for this one, and it will work for any one of these problems. And that is to realize I will always set this up in a way that I can do this as 1 over 3 to some power. That's how these will all work. So what I'm going to do is I'm going to assume that Mr. Pabian set this up correctly, where I can do 1 over 3 to some power. Let me put the other side, and let's talk about what I'm doing. 1 over 3 to some power should equal 1 over 243. I just got to figure out what number goes here. The good news is you have a nifty calculator that you can just go, make sure it's in parentheses. You can go 1 over 3 squared, 1 over 3 to the third, 1 over 3 to the fourth, 1 over 3 to the fifth, 1 over 3 to the sixth. And we could figure out what number goes there. And then we'll talk about why we're doing that in just a second. So we're going to go ahead and take our calculator, and we're going to test that. So 1 over 3 to what power will give me 1 over 240? Leave him, make sure you plug in 1 over 3 to the fifth. Make sure you use parentheses. That would equal 243. Here's where it's important. 1 over 3 to the fifth must equal 1 over 3 to the fifth. That's all 1 over 3 to the fifth equals is 1 over 3 to the fifth. So note where your 5 is and where your n minus 1 is. We have a 5 here, we have an n minus 1 here. Those have to be equal to each other for this to be true. 1 over 3 to the fifth has to equal 1 over 3 to the fifth. Well, right now we have n minus 1 occupying that space. So we're allowed to say, okay, that means 5 equals n minus 1. Add 1 to both sides, and you're coming with n equals 6. Sorry, there's not a ton of room. I'm going to block that off for our sum. Good thing is our sum, we're going to do most of it. All right, questions on what I did here? So once again, I did the exact same thing I would with for an arithmetic. Just like Theo said, just plug in your last term here. The hard part is solving it. Recognize that on these problems, I will make sure that these even out. Okay, now we're going to do our sum. Our sum is a formula we're not going to do on our head. And let's be careful with our calculator. So I'm going to write it, and I'll tell you how you need to plug in your calculator. So our sum is our first term, which is 1, times 1 minus my r value, which is 1 over 3, to the nth value, which is 6, all over 1 minus r, 1 minus 1 over 3. Like I said, we started off with the hardest problem possible. So don't expect them all to be this way. Now, in your calculator, if you look up here, I'm going to put yellow around where you need to put parentheses. Make sure you put parentheses all around your numerator and put parentheses all around your denominator. The only one that's really needed is your denominator one, because we already have parentheses that will take care of everything. But get in the habit of anytime you're putting a fraction in, that you put parentheses around your numerator and you put parentheses around your denominator. I'll give you guys a second to actually plug it in and check it, but you should come out with about 1.5. But don't just... Does anyone know how I know the next one is geometric? I should backtrack to that. Let's go back to actually asking you that question, is it geometric or arithmetic? How do I know that this is in fact geometric? Yeah. There's a variable in the exponent. This is exponential, which means it's geometric. Exponential means geometric. You need to be able to pull that out on the test. You need to recognize that. So exponential equals geometric. Exponential equals geometric. Exponential equals geometric. Write that down if you did not know that going into it. When Jacob said that, you were just like, well, didn't know that. Make sure you write that down. All right. Since it's exponential, it's geometric, which also tells you know your R value. Your R value is going to be this value right here, that thing that's connected to our exponent base. So that's our R value. Kind of a trick question, but not really. Just really think about this. How many terms are in this sequence? How many terms are in this sequence? And don't just look at the top number and say, that's got to be it. Yeah.
11.
It's going to be 11. Our n is 11 because we do not start at 1. 1 to 11 is 11. 0 to 11 is going to, 1 to 10 would be 10. 0 to 10 is 11. So that makes our n 11. Okay, so now we can do our sum. Our sum is going to equal our first term, 100, times 1 minus r to the n. Our r value is 1.5, so we have 1 minus 1.05 to the nth, which is 11. And that's going to be all over 1 minus 1.05. All right, let's try to plug that into our calculator and see what we get out. Maggie, so I think I know what you did wrong on the other one.
Okay.
So just be very careful with your parentheses. That I think possibly, as you're typing it in, I will give you the total sum to see if you got it right. You should have came up with 1,420.7. Does that seem good? Happy with that? Okay, good. This is more traditional of a problem. This is a tough problem, the first one. So don't get bogged down in a tough problem right off the bat and go, I can't do any of this stuff. This is our traditional problem that you just have to be able to locate its geometric, and you have to know the formula. This is a tougher problem. All right, let's move on. Infinite geometric sum. Let's go back to arithmetic. If you have an arithmetic infinite series, you cannot come up with the sum. So arithmetic is either it's finite, you can do the sum, or infinite, you cannot. That is not true for geometric. There is one type of geometric you can find the sum of. So the first thing we're going to talk about is how do I know if I can find a sum or not with an infinite geometric series. So what you need to look at is your R value. You're going to look, is R bigger than 1, absolute value of R bigger than 1, or is your absolute value of R less than 1? If it's bigger than 1, we might have something like this. We have 13927, which means our R value would be times 3 times 3. Our R value would be 3. And if you did that test, absolute value of 3 is bigger than 1. In these cases, since it's an exponential function, picture what an exponential graph looks like. An exponential graph that goes 3, 9, 27, it's going to keep getting bigger and bigger and bigger very quickly. This is known as divergent. Just looking at divergent, does it look like we're going to be able to come up with the sum of this? Because every time I go one step further, it's bigger. Another step forward, it's bigger. Divergent means you cannot find a sum. Yep.
Would the sum just be infinity?
Yeah, it would technically be infinity, but
Oh, no sum. Okay.
because we're going to put no sum. Because if I ask for the sum of something and you say it's infinity, that's kind of like saying I can't come up with the sum of it. So we're just going to go, okay, if my r is bigger than 3, I can't come up with a sum. Awesome, I'm moving to the next problem on the test. Harder version is if your r is less than 1. In these cases, in this case right here, r equals 1/3 because we're multiplying by 1/3. You look at the absolute value of 1/3, that is less than 1. What happens here is our numbers are going to get exponentially smaller. So our graph is going to look kind of opposite. It's going to come down, and it's going to get smaller and smaller and smaller. Now, eventually, this is going to reach 0 at infinity. And we can actually get that value. Infinity is weird, but we can actually get that value. We know what happens when this converges at 0. So this is called convergent. And we can actually find the sum. In fact, the sum is going to equal your first term divided by 1 minus r. It's actually an easier formula. So divergent, no sum. It just keeps getting bigger and bigger and bigger. If our r value is less than 1, absolute value is less than 1, we can come up with the sum, and it actually has a nice, nifty little formula. It's actually easier to calculate than the other one. So I actually have both those formulas right up here. So if you didn't write those down, we got them right here. Geometric sequences. So your job on the test, if I say come up with the sum of these, first, is it arithmetic or geometric? If it's geometric, we got more steps to do. Is it finite? Yes, I can do a sum. Is it infinite? If yes, we can come up with the sum if our absolute value of our r is less than 1. Very related, but kind of a side question. Why do you think I put absolute value of r has to be less than 1? What values do I want to exclude? Yeah. Certain negatives, right? Would negative 0.5 work for this? Would negative 1.5 work for this? No. So I want to get rid of that negative aspect. So basically I'm looking, is my value between 1 and negative 1? If it's between 1 and negative 1, it fits here. Anything outside, nope, don't have to do the sum. All right. Our next ones, we're going to go away from the sum for just a second. And we're going to use summation notation to write the sum of these. And really, I just want us to practice using our calculator real quick. Okay, we're going to use summation notation to write the sum of these two things. So we're going to take a quick break from summation, from finding the sum, and we're going to write summation notation. We've done this before. We've said, oh, okay, well, if it's geometric, I'm multiplying by 3, multiplying by 3, my r equals 3. I also have my first term equals 5, which means I can do my summation formula. I can go, okay, first term is 5, common ratio is 3 to the n minus 1. I can go, okay, my n starts at 1, and then I go, uh-oh. I need to find my nth term. I don't know what my nth term is. Let's quickly look at the way we just learned how to do this. So real quick, I'm going to back up. I'm going to come back to this slide if you don't have it down. This works. Come up with your formula, plug your last term in, solve for your n. How about we let our calculator do this for us this time? We're going to learn a new skill on using our calculator. So other method still works here. We could come up with our explicit formula, which we already have, 5. So real quick, don't write this down. I'm just saying that this is how we could do it. We could do it as 5, 3 to the n minus 1, plug this number in, and solve for our n. I'm not doing that. I'm not doing that. We're going to use our calculator. So to find our n, we're going to use our calculator. Put whatever notes you need in this little box. It's not a lot of room, but that's what we're going to use. We're going to take out our calculator. We're going to close that down. We're going to take our calculator, make sure it's on. And then we're going to hit our y equals button. All right, y equals button is right in this top left. Does everyone say y equals? Are we okay with that? Okay, I just want to make sure we're in the right mode. All right, what I want to do now is I actually want to write that formula in. So that formula from our notes, actually get mine out, is that 5 times 3 to the n minus 1, right? That's the formula we just had in front of us. We're going to type that in. So we're going to go 5 times, and what is it, 3? And then let's make sure we know where our raise power button is. That's that little caret button right on your right-hand side, right under clear. I'm going to hit that little caret button. I'm going to hit open parenthesis. And we don't have an N button, so we're going to use our X button. Our X button is right on that top left. It says that XT theta N. So we're going to hit that X button. And we're going to hit X minus 1. What I'm going to let the calculator do is I'm going to let it plug in 1. I'm going to let it plug in 2, 3, 4, 5, 6, 7, whatever I need to get to the value I'm looking for. So I'm going to let my calculator plug that in. What's going to allow you to do that is look at your graph button in the top right. Don't hit it, just look at it. Look at right above it, it says table. That's going to be your table of values. That's going to be your calculator plugging in a whole bunch of values for you. So what I want you to do is I want you to hit your second button and hit that table button, that second graph, which will bring you to your table. On your left-hand side, that's what term number you're on. So mine right now is focused on my second term equals 15. If I plug in 2, I get out 15. If I plug in 3, I get out 45. If I plug in 4, I get 135. If I plug in 5, I get 405, 6, 7, 8. Well, look at number 7. If I plug in 7, I get out 3645. That was our last term, right? In the thing? Yes. So that means my n at 7 is going to equal 3645. So by using my calculator, I can go n just equals 7. So from that little table, we would have basically 7, and we'd have that equals that 3645. This was our table button. That's a little bit easier. Now I can just put 7 right here. Done. It's a little bit easier than going through that way we did it on this problem. Well, less writing at least. So that just involves us writing the equation in our calculator and going to our table. We're going to do that again for the next one. So our next one we're going to do as much as we can. We're going to notice that we are multiplying, but this time we're multiplying by a negative, so it's times negative 1 times negative 1. It is geometric. More importantly, it's geometric with a common ratio equals to negative 1/2. Our first term is 48. So the beginning of our summation is going to be our explicit formula. Our explicit formula is our first term times our common ratio to the m minus 1. N equals 1. Our job is to find what our last term equals. Now, quick, before you plug in your calculator, because that's what we're going to do next. We're going to plug that 48 times negative 1 over 2 to the n minus 1. It's going to give you answers in decimals. Does anyone know what 3 over 16 is in decimal form? Probably not. Plug it in first. Go to your home screen, plug in 3 over 16, figure out what about that decimal equals before you go back. So we're going to say that's what, 1.87? 1.87. So when we plug this in our equation, our table, we're looking for where it's about 1.
Oh, wait, no, sorry, it's 0.187.
0.187. Okay. Yeah, it has to be. Yeah, if I just thought for a second. So that's what we're looking for in our table. So let's go ahead and plug in this equation. 48 times, in parentheses, negative 1 over 2, close parentheses, caret button, open parentheses, n minus 1, close parentheses. So make sure you're putting parentheses around that negative 1, and I'd also put parentheses around that n minus 1. Let's go ahead and plug it in, go to our table, and let's find out what value 9 is correct. Our n would equal 9. You should get 9 in that. I'd love to spend more time on our calculator. We just don't have time, but that's a good way to do it. Don't forget about that table. That table is actually very useful in other math classes as well. It's a really good way to get a bunch of values really quickly that you're not plugging them in. And guess what? This whole chapter is about getting out sequences. Turns out our calculator can do sequences the whole time. So if you apply this to other concepts, you can use that to check your answers on the test. But that's up to you practicing your calculator. So this will give you sequences right off the bat. All right, let's do some sums, some actual sums. All right, 8, 4, 2, 1. Here are the two things you're going to check. First of all, is it geometric or arithmetic? What is this one? It is geometric. So that's our first check. Is it geometric or arithmetic? It is geometric. It is multiplying by 1/2. So that's my first thing. I'm going to go, okay, that's geometric. Before you do anything else, check to see if it's infinite or finite. Since it's ... that means it's infinite. If this was arithmetic, I would say I can't do it. Since it's geometric, I'm just going to find my r value and make sure I'm allowed to do this. So my r value, in this case, equals 1/2. I'm going to check to see, is the absolute value of 1/2 less than 1? It is. It has a sum. That works. It has a sum. The nice thing is our summation formula is really nice. It is just our first term divided by 1 minus our r. Note we don't have any n's. We can't. That's infinity. So we just need our r and our first term. Well, that was just going to equal 16. Knowing that this would be 8 divided by 1/2. Keep change flip. That would turn to 16. Someone else besides whoever, I forgot who told me last time, but how do I know this is geometric? Our first thing is to check if it's geometric. How do I know that this is geometric? I'm on the test. I have to say why it's geometric. Why is that geometric? Yeah. It has and be careful, it has a variable in the exponent. A variable in the exponent, which means it's exponential. Exponential equals geometric. Exponential equals I'm not sure if I said that yet today, but exponential equals geometric. So I'm just looking at the n minus 1, and I know that's geometric. Since it's exponential, the base of the exponential is going to be your r value. Your common ratio is going to be that 2. My common ratio is 2. That's bigger than 1. Can I find the sum? My r value is bigger than 2. Am I allowed to find the sum of this one?
Yes.
Why?
It's not infinite.
Because it's not infinite. I told you your first two things. I forced you to think ahead. First thing is it geometric, arithmetic? Second thing, is it infinite or finite? This is finite. Finite will always have a sum. So I don't have to worry about the infinite thing. So it's finite, so it has to have a sum. As a reminder, to get the finite sum, we need to know the first term, and we need to know the last term. So our first term is going to be, I don't need the last term. I'm sorry. I was thinking, anyway, we need our common ratio, our first term, and we need our n. That's the one we needed for this one. For arithmetic, we need the last term. All right, so our first term is just 2 to the 1 minus 1. 1 minus 1 is 0. 2 to the 0th is 1. This is the more complicated formula. This is S equals our first term, which is 1, times 1 minus our r value, which is 2. Raise that to the nth power, which is 7. All over 1 minus 2. Just to speed things up, I'm going to give us our answer. We should come up with our sum equals 127. I just don't want to run against the clock right now. All right, next one. Are we good? 127? Okay. Our next one, we're going to check to make sure it is geometric. It is geometric. Next check, is it infinite? Yes, it's infinite. Infinite means I need to do the check. I need to check my R value. Well, my R value, my common ratio is that negative 0.99. The check is absolute value of negative 0.99 less than 1? Yes, it is. So it's convergent. Convergent means I can find the sum. To find our sum, we just need the R value, and I need the first term. Our first term is plugging in 1 for j. So we are going to have 100 times a negative 0.99 to the first, which should come out to a negative 99. That means our sum is going to equal our first term on top, 1 minus r on bottom. So that's 1 minus a negative 0.99. Once again, for sake of the clock, I'm just going to give you the value. That comes out to about negative 49.8. And what? We got a couple minutes. Look at D. Why can I not find the sum of D? Why can I not find the sum of D? So in this one, I can just put no sum. Well,
Because the R value is greater than 1.
the R value is greater than 1. So I would have checked. I would have said, well, this is geometric. This is infinite, so I have to do the check that Will just said. And the check is, look at your R value, which right now is 1.01. It looks bigger than 1, right? Absolute value of 1.01. Let's write neater. We got a little bit of time. 1.01. The absolute value of 1.01. Is that less than 1? It is not. Nope. So that means there's no sum. Like Jacob said, that would be infinity, but we're just going to put no sum. Because you can't actually calculate infinity.